So we'll get started then. My name is Dean Barrett. I'm with BARR Plastics, and today I'm going to talk about solutions for sustainable construction. And we have a few different product lines that we supply into the construction industry, and we'll touch on that. So the topics we'll discuss are sustainable construction, stormwater management, rainwater harvesting, and greywater recycling. A little bit about BARR Plastics. We're a family-owned local business established in 1968, and we've been located in Abbotsford since 1970. We're originally heavily involved in the agriculture industry and dairy farming, feed silos, feed automation systems, manure pits, concrete construction. We have a staff of 33 amazing people dedicated to great customer service. We're a leading distributor of plastic tanks and liquid handling systems in Western Canada. However, we do sell all across Canada and North America. A Canadian distributor of world-leading products for rain harvesting, stormwater management, wastewater treatment for Autograph Company of Germany. So we're the Canadian distributor for their product lines. And we're one of Canada's largest suppliers of stormwater management systems. We've supplied over 2,000 systems across Canada to date, mainly in BC, Alberta, and Ontario. And those are the key markets where it's required. Other provinces haven't really got onto it yet, but I think they'll all be coming on board before too long as we keep seeing changes in rainfall patterns and flooding situations. We're a custom fabricator of plastic tanks and liquid handling systems as well. So we have a full service plastic fabrication and plastic welding shop with 5 fabricators. We're a major supplier of salt brine de-icing systems for municipalities and highway contractors across North America. And recently we have a 7 system brine making system being shipped to the Department of Transport in Texas. So we have our salt brine systems in states all over the US. We're a Western Canadian distributor for Hydroloop Greywater recycling systems as well. So we'll start with stormwater management. And our product is called EcoBloc, and it's a modular stormwater management system. So all new construction now in British Columbia requires stormwater management on site. Now I'm talking right now of commercial, large multifamily developments, etc. Not all single-family residential requires it yet, but it is required in certain municipalities and maybe in certain areas in municipalities. Abbotsford is starting to require it in certain developments where they don't have adequate stormwater infrastructure. And City of Vancouver is requiring it on all new construction, including single family, as of July 1st, 2025. North Vancouver's been doing it for a long time. Chilliwack does it in certain locations, and I think it's going to become more mainstream. One of the main challenges that municipalities are facing across North America is aging and undersized infrastructure that is not adequate to meet the demands of current development trends. And we all know, it's in the news every day, we need more housing. But the infrastructure is not there to really properly deal with it. So municipalities are looking at tools to kind of decentralize things a little bit and manage more of it on site. So most of the systems that are being installed are detention systems. So the blocks create underground void space to capture high volumes of stormwater during heavy rainfall events. And then there's a flow control outlet that controls the rate of flow into the municipal storm system. So what they'll do is in a heavy rain event, the system will fill up and it'll slowly drain out into storm sewers. And they size them, civil engineers will size the systems based on the amount of hardscape and collection area on each specific property. So they're all site specific, and so every one has a different volume. There's no standard to it. It's based on site specifics. Ideally, infiltration systems are probably the ultimate goal. The system has a 96% void ratio, so it's the most efficient as far as volume for the space available. Traditionally, we've used rock pits, tunnel systems, and they use just gravel as storage volume, but it's only 33% void ratio, so it's highly inefficient. And aggregate costs keep going up as well. And typically they're designed to capture the volume of a 100-year storm event and then slowly infiltrate the water back into the ground. So this helps prevent flooding and recharges the aquifer. We've seen aquifer levels in the Lower Mainland drop due to increased hardscape and just piping the water away into streams, which creates issues for salmon-bearing streams because you got all kinds of particulate and other debris getting into streams, and then it eventually makes its way to the ocean. And so we want to try and manage more of this on site. Here's a little video on the system. That system's in Norway. So, quick little video there. Oh, stop. Okay, we're just going to show a few projects that have been done. These are, I focused it all basically on local projects so we can see what's been done in Abbotsford. I don't know if I mentioned this, but we have now sold, in the last 10 years, we've done 2,000 systems like this across Canada. And we've been growing rapidly every year. The demand for this is huge because of the development that's taking place all across the country. So the first one there on the left was at Golden Valley Fluids on Mount Lehman Road. They built a large new truck parking area, and they needed to also upgrade their stormwater volume for off of the building. So this is a direct infiltration system, and I believe it's only the 2 rows deep, so very low profile, but you can see the soil depth. It's a very deep burial. So that's where our loading capability comes in and makes it a superior choice for this type of application. So on that particular site, they have well-draining soil underneath, so they can infiltrate all that rainwater back into the ground. On the right there is the system just next door here at the new Abbotsford Police Department addition. And this one kind of showcases the flexibility of the project and how you can fit certain spaces. You can see it's stepped into kind of a triangular shape there. And then inspection shafts on each corner.
How much would a system like this cost to put in?
It really varies, and it's based on site specifics. So, but I think you're in the range of about $500 to $600 per cubic meter installed.
How have jurisdictions done with upgrading their requirements and stuff to have it be accepted within construction standards and stuff like that? Has that been a challenge for regulatory?
No, it hasn't. No. We've never had a system rejected in any municipality and they don't want to do that because they want options available and they want to require it. They just, and you know, there actually is no current standard in North America for modular block systems. They have standards for tunnels, but they don't have standards for modular block systems. I heard something is in the works to try and come up with a standard through ASTM. So, you know, that may be in the works, but we have countless third-party testing, countless approvals in Europe, and a lot of those jurisdictions actually exceed what is required in North America. So, you know, we've been installing this now for 10 years.
Can I ask you about both of these? The Golden Valley one, you said it drains into the soil below?
Yes.
So I know there's a stream close by there. How it doesn't have any impact on that stream, eh?
It shouldn't.
Okay.
And I mean, in a situation like that, the stream is far enough away that the soils are going to do a lot of the filtering of anything that gets into the ground. Where you would have more of a problem is if you were just going into catch basins and piping that water right into the stream.
Right. And what about the police department building? Where does that drain into?
That drains into the storm sewer. Yeah.
And the storm sewers drain into the creeks?
Eventually, probably, yeah. Yeah. And into the Fraser. Yes.
Can I ask one more thing?
Sure.
Have you ever been required or to put in any kind of a filtration system for toxins or
yes.
chemicals?
Yes. Generally, toxins or chemicals are typically not addressed. What is addressed is hydrocarbons. And and I'm sure that on that system at Golden Valley, we normally don't supply that component, but I'm sure they would have required an oil-water grit separator before it goes into the system. And generally in Vancouver, they require even higher levels of post-filtration before it goes to storm sewer into the ocean. So there, yeah, and you know, and they may increase those requirements down the road. Who knows, right? But there is constantly cleaning tools being developed. Yes?
What's the lifespan of one of these systems?
Oh, we're saying minimum 75 years. Yeah. You had a question?
Yeah, I'm curious about how this gets put together. It looks like it's filter cloth on grade of some kind, and then on top of the system is quite porous. So if it was just moisture it'd be getting in there, is it?
It's completely wrapped. Yeah. So when we do a detention system like the one on the right, it'll be 3 layers. We'll lay down a layer of geotextile. We'll lay down a polyethylene liner. And then we'll put on another layer of geotextile. So the liner is sandwiched between 2 layers of geotextile all the way surrounding the system.
Okay, so it's not meant to be porous on all sides?
No.
Okay.
Unless it's an infiltration system. So like the system on the left, all that's happening there is it's wrapped with 1 layer of geotextile. And then we'll put a layer of crushed rock on top, about 4 inches, and then you can go native soil from there.
Okay.
Yeah.
Could you pour a slab on top of this?
Yes. Yes. And we'll see one later on, which is our largest system that we've supplied in Canada, and it is under a paved surface. In fact, most of them are, like both of these are under pavement. Yeah. And the one that, the big one is under a concrete slab. That's this one here. So this is our largest system to date. It's 3,000 cubic meter, and it was for a distribution warehouse, and it's right on Mount Lehman and South Fraser Way, right next to the traffic circle there. You can see Fraser Way RV in the background on the left. And so this one is a detention tank, and on top of this one, because it's got heavy loading trucks on it all the time, they poured a concrete slab on top of it. But just to give you you can see it's a fairly large tank, and that's 3,000 cubic meters. The largest one built to date has been in Kuwait, and it's 50,000 cubic meters. It's just absolutely massive. And that was, they built a brand new city for 500,000 people, and I think they put in something like 16 detention tanks. But that was the biggest one, 50 million liters. Yeah. So here's another, like a 300 cubic meter system, that one on the left there. That's probably a really typical size for the majority, are kind of in that 300 to 500 cubic meter range. But we get, you know, and then as small as 5 cubic meter for residential. When we first started out 10 years ago, the majority of the ones we were doing were small residential systems. A lot of them in North Van, West Van. But that's something that, you know, they're considering for individual homes. Tanks are also an option for stormwater detention and residential, and we'll be covering that off in a little bit. The one on the project there was the strip mall right adjacent to High Street, between High Street and the freeway. And that project there had 2 detention tanks like this. And they're all situated under parking lots. We do a lot of, probably the majority of our projects are multifamily construction. So, you know, though I think the one on the left is high rise. And so we can actually, because of the modularity of the system, we can adapt it to really tight situations. So you look at that, I mean, it's just barely fitting in there. And they're gonna get, you know, some gravel around the outside edges to support it. But, you know, working around all that piping, it just shows the versatility of the product. The one in the middle was actually replacing a pond. So that was a long time detention pond, but it was never being properly maintained. It was full of reeds and cattails and stuff, and they wanted to utilize that space. They were building a brand new container storage yard down in Delta, and so they wanted to reuse that for parking and to put office trailers on. And to put that system in, to re it and pave everything cost them $600,000, but they gained back $1.25 million in real estate that was usable versus a pond that they had to maintain on a regular basis every year.
Quick question. I know like stormwater is like a big thing part of LEED and new constructions. Do you guys work with LEED or anything? So like upcoming buildings could get like points for this? Like,
yes.
towards like LEED standards?
Yeah, LEED, you know, will allocate certain amount of points for various different things such as stormwater management, rainwater harvesting, greywater recycling, any green initiative, you can get LEED points for it. Yeah. So these just show how, you know, you can fit the system into, and on high-rise construction, we often just basically have the space right tight against the building underneath the sidewalk or laneways, or these might even be, this is probably going to be a sidewalk in front of here. It looks like it's a laneway down the side. So, you know, fitting into very tight spaces, utilizing whatever stormwater volume they can. And a lot of high-rise construction, they're building right to lot lines. So the only option they have often is inside the underground. So we have solutions for that as well.
Have you ever, like gone into an existing residential, like commercial or industrial site and dug up a parking lot and put one of these in?
To my knowledge, we have not. If, say, there was a situation where somebody was adding on to a building and maybe doubling the size of the building, they would probably have to upgrade their stormwater capacity. So then we would just install one for that new portion of the building. and maybe tie it into an existing one. But yeah, not often do you see this being retrofit. And even in Abbotsford,
Yeah,
most projects used to have poured in place concrete tanks. And that's been normal for many, many years. And in our building, actually, we have a concrete tank. And that building was probably built back in the early 90s. And so it was pretty standard even back then.
we're just trying to save a wetland from being a detention pond.
Mm-hmm.
So this is very interesting.
Yeah. So I mean, obviously upstream of the wetland, any new construction, if you put this in and manage it on site, and possibly, if soil conditions allow, I'm kind of a little disappointed that they don't do more direct infiltration. Like 90% of the projects are detention and slow release. But I think they have concerns about, groundwater getting into basements, or on slopes, you don't want to add more groundwater, because I guess you're kind of concentrating it a little more than it used to be. It used to be spread out over the whole lot. Now it's concentrated in a smaller area, so you could get more water going into a focused area that may cause slippage on a slope. So that's why we're normally seeing detention. But the Campbell Heights industrial development is all infiltration there, because they're on a big bed of gravel and they can do it. And they had no stormwater infrastructure. So we'll touch on rain harvesting systems a bit now. So carrot tanks, these are all made by Graf of Germany, and they come in the sizes shown there. And they're 100% recycled product. So very friendly as far as plastics go. And we use these for stormwater management, detention systems, rainwater harvesting, and septic applications. So we have our tank. They're a two-piece tank joined in the center with a rubber seal and clips. So what that does is makes them very efficient for shipping. So we can actually ship 5 tanks per tank space. So it's a 5-to-1 shipping ratio. So in a container, we can get 25 tanks. So it makes them quite efficient. And that's the only reason why we can cost effectively ship them from Europe. And the quality of the tank is pretty much superior to any other tank made in North America for this kind of application. They're more robust, they're stronger. Most tanks are made out of rotomolded polyethylene. These tanks are made out of injection molded polypropylene, which is a much more rigid material. The only, I guess, drawback is it's more brittle. So they have to be a little more cautious handling the tank and not, bashing it with an excavator and that kind of thing. But the other things they have is a lot of good options as far as lids, domes, risers, extensions. Every joint has a rubber seal, like a high quality seal, so it prevents water from getting out and it prevents groundwater from getting in. In Europe, in some jurisdictions, such as Belgium, they require testing of these tanks to the top of the dome. So that 2-foot riser on the left of the tank photo there, they fill it, they put it into a tank and they fill the tank with water on the outside, and they can have no water ingress into the tank. So it's tested to a very high standard, and that's the highest standard that I've heard of in the world for testing of septic tanks. So that's to prevent septic waste infiltrating into the ground or extra water getting in. And those are generally used, they do a lot of packaged sewage treatment systems in Europe, and these tanks are used extensively for that. We also sell Graf's on-site sewage treatment systems here in Canada. So we have all the different lids and risers. The other huge bonus with these tanks is they can handle light vehicle traffic. So they're suitable to be installed under residential driveways. And with what's happening in Vancouver, turning a single family lot into a sixplex, it's pretty much all hardscape. You might see 1 or 2 parking spots. And underneath those parking spots is pretty much the only place they can put a tank. So that's where these tanks are going to shine in those kinds of really tight space applications. We also have a variety of different filter options. So the Carrot S internal filter package there is good for Rainwater harvesting, say in the home for toilet flushing and laundry. You would put a supplemental filter after that as well, but this is prior to the rainwater going into the tank. So to get the cleanest water possible into the tank. The basket filter on the bottom is typically used for garden or irrigation type systems that don't require such a high level of filtration. Now the top filter, it only collects about 95% of the water that goes through it. The basket filter collects 100% of the water goes through it. So here's a typical tank installation where this is being used actually for on-site infiltration. And you'll see it's using the basket filter, keeps debris out of the tank, so you don't have to clean out your tank all the time. Because if you let leaves and debris go into your tank, it's going to go foul smelling on you, which isn't really a big deal on an infiltration system, but it's just easier to take the basket out 3 times a year and dump it out. And here's another tank option that we have. It's called the PLATIN, and it's a low profile tank. These tanks are a single piece molded tank. They're not nestable for shipping, so they're not quite as freight efficient. But due to their dimensions, they are as efficient as they can be inside of a shipping container or a truck. So basically a tank like that, 15,000 liter, will be just under 4 feet tall. So they can stack 2 high in a container, and we can get 4 of them in a container. Or we can get a combination of big tanks and small tanks. They're a super high quality tank, very strong. They can handle groundwater up to the top shoulder of the tank, and they can also handle light vehicle loading. And with a concrete pad on top that extends past the edge of the tank by about 4 feet in all directions, we can go up to 30-ton vehicle loading. They're available in multiple sizes. 25,000 liter is the biggest one we can ship here. They make them up to 60,000 liter in Europe. Smaller versions, they come with a built-in riser and inlet and outlet ports for piping going in. Oh, that was a little quick there. Yeah, and suitable for light vehicle loading and groundwater stability. Good for installation under driveways. And again, the PLATIN tank uses virtually all the same accessories and filter packages that are available for the Carrot tanks. And so these tanks are primarily being used for rain harvesting, stormwater management, and sewage holding. They also make a potable water version that's available as well. And one of the most recent ones we installed, a guy built a new shop up in 100 Mile House, and he put a 7,500 liter under the floor of his shop to collect all the rainwater off the roof and to use it for pressure washing, etc., and irrigation. And there's an example of a PLATIN tank set up for direct infiltration again. So we just basically install it, connect perforated pipe around the perimeter of the tank, and it'll infiltrate back into the ground.
Can you use any of those as cisterns?
Yes. Yeah.
So you just not have the drainage pipes?
Correct, yeah. And here's an example of a combination system. So we can set up, we can do 2 functions in one tank. We can collect rainwater for reuse and do stormwater detention in the same tank. So we retain the bottom half of the tank to store water and the top half of the tank to fill up and then slow release. So we've done a few systems like this. They're definitely a lot more common in Europe, but even with comments I've seen out of the city of Vancouver lately, posted on LinkedIn saying we need to do more rain harvesting. So they're finally coming to the realization that, you know, even after spending billions of dollars on upgraded water treatment infrastructure, we're almost maxing it out already as fast as it's being built. So we got to start doing more stuff on site and saving water and using water on site. And that's where we're heading. The reason that Europe and other jurisdictions are so much farther ahead on this kind of stuff is because their cost of water is much higher. So they get a much quicker ROI on these types of systems. I'm not even sure what Abbotsford current water rate is. Does anybody know? I believe it's minimum $2 a cubic meter for water. And I think septic may be calculated on top of that. So I think we're anywhere in between the $2 and $3 per cubic meter range. Europe is in the €5 to €7 per cubic meter range. So, they're in the $10 a cubic meter to our $2 to $3. Although I just heard that any residences in Silver Star Resort in Vernon, they're paying $9.70 now for water, because they're getting water from a private system, and that's the actual cost. Most municipalities don't charge. They charge for the annual operating and maintenance of the system factored into the water rates. They don't factor any new expansion of infrastructure into the rates.
So it's subsidized from other revenue streams?
Yeah, they just basically,
Development cost charges
yeah.
for the new.
Yeah. But I mean, anytime, new infrastructure is needed, everybody's, okay, some money's paid by the municipality, some money's paid by the province, some money's paid by the feds for any major infrastructure project, pretty much. So I think that's kind of what they're relying on instead of, and I think, I don't know for sure, but I think municipalities maybe aren't allowed to develop huge amounts of cash reserves either. So they're not allowed to say plan 5 years ahead and say, okay, we need to do this. Can we add an extra $1 a cubic meter to the water rates for 5 years? And then we have this pile of money to use for the new upgrades. I think they get less funding from the province and from the feds if they have more of their own money. So it's I don't know.
This is good where there's like rain shadow, like, when I lived on the Gulf Islands, and they have a lot of, they're starting to have more and more rainwater collection systems.
Oh yeah, big time. That's where 90% of the rain harvesting systems in BC are, is on the Gulf Islands.
And one of them even had, they used it for their potable water.
Yeah, quite a few places. I think it's Galiano Island. A lot of people there are solely on rainwater for water supply. A lot of the wells are going saline on the Gulf Islands because they've been pumping too much groundwater and they're getting saltwater intrusion. So all kinds of issues. And just to give you an idea, the west coast of Vancouver Island, Lake Tofino, gets about 150 inches of rain a year. The Gulf Islands get about 35, just like Victoria. North Van gets about 80. City of Vancouver gets about 45. So crazy low compared to North Van, 15 minutes away, right? Abbotsford historically was getting about 62, but I think it's dropped down somewhat. But who knows? If we could get current data up to the day, we'd have a much better idea of where we are. But I think it's improved a little bit through Weather Canada, but it used to be horrendous getting any kind of updated current rainfall data. So we'll just look at a few past projects with carrot tanks. So this was a project done at Mission Institution. That blue building, they have a composting facility where they compost all of their organic wastes from the institution there, and they need water for that. They need to keep the compost moist, so they decided to install a rain harvesting system to collect the water off the roof and then use it for the composting process. So just, I think they had some money for green initiatives, so that's what they chose to do in that case. And that was probably done 10 odd years ago. Here's a couple of residential projects. The one on the left at Gladwin Road, that's actually my place. Put that system in when we built a coach house, and we used the water for toilet flushing and irrigation. And that was probably one of the first systems approved by Abbotsford for toilet flushing. And that was built roughly 6 years ago now. And then on the right-hand side there, that is another residential build. That's out on Ross Road. I forget what they call that development now, but it's out by the winery out there. And so this is the largest residential system that we've supplied so far in Canada. And that was 3 times the size of mine, so it's about roughly a 57,500 liter system. And he's, I think he's got close to an acre lot there. And he collects enough water to irrigate his property and toilet flush. He usually has enough rainwater up until the end of August. But this last year or so, we've seen a little bit more rainfall in the summer, so that helps. We used to get 2 inches a month, and for years we didn't get any, hardly. I think the year before last, I think we only had like 5-10 millimeters in the whole summer between June and September. We used to get at least, we used to get about 200 millimeters each month.
Do you know if they've looked, McKee Peak Development has looked into something similar to the last slide?
McKee Peak.
That's the one up on Sumas Mountain.
Yeah, I know that we were talking to an engineer on one development up there, and I know they were going to require stormwater management on each lot, but nothing on rain harvesting. There's no big incentives by any jurisdiction really in BC to do rain harvesting, except for Nanaimo. Nanaimo is one region that is offering incentives, but I think they limit it to about 20 systems per year.
Abbotsford does, but it's very small. They used to give special price if you bought a rain barrel.
Oh yeah, yeah. And
But nothing.
yeah, and they decided to get out of rain barrels because
Yeah.
they did a study,
Yeah.
and the study showed that it provided absolutely zero value.
Yeah, they're kind of small.
Yeah, and when I first got into rain harvesting about 15 years ago, it kind of was starting to ramp up around North America because of all the drought in the Southwest, and so I figured, oh, cool, I'll get a rain barrel, I'll put it on my downspout. So I set it up one day and it rained, and I go, oh, got all excited. I went outside and the barrel was full. And I hooked up a soaker hose. I had about a 30-foot flower bed, and I turned the tap on and came back at the end of the day. Oh, flower bed's nicely watered. Barrel was empty. Didn't rain for 3 weeks. So I got 1 day of watering out of that effort. So to really have any kind of effect, you got to maximize the maximum amount of volume you can possibly put in. I'm only actually collecting on half of that roof area on that building. It's about a 3,500 square foot roof, but I'm only collecting off of about half or a third of it. And that would fill my tanks up. So they'd be full in the spring, and every time it rained, they would top up again. But I'm using it constantly for toilet flushing. But now we built an addition of almost another 3,500 square feet. And so now these tanks are gonna, and that's connected to the full roof of that building. So that they're gonna be full more often now and catch a lot more water. The average house, say, older, smaller homes, 1,500 square foot roof, the multiplier is about 0.623. So about 800 US gallons per inch of rain. So 8 times 60, so 48,000 gallons roughly a year you can collect off the average home. So that's a lot of water. And that's roughly half of what an average home will use in a year. So if you could put in the appropriate amount of storage, say 3 tanks like that, and we've seen this done on quite a bit of new home construction. I obviously thought this rain harvesting thing was going to take off way faster and way larger than it has, but it is starting to really ramp up. I mean, places like California, Florida, they're really ramping it up because they just virtually have no water. And so they're going to, and there's been other places, even in Ontario, where developers came with a proposal to do a huge new development, thousands of new homes, and the municipality said, we don't have the infrastructure. Where are we going to get the water? Where are we going to get the wastewater treatment? So we got to start taking measures like this, but it's really slow to happen. I mean, in BC, the attitude is we have a ton of water, which we do. We got lots of water, but we don't have a lot of potable water that we can get to the end user effectively and cost effectively. And I mean, we're just going to have to keep expanding the infrastructure, which is a necessity. But one of the reasons that Vancouver is going to on-site stormwater management is because some of their, the majority of their sewer system in certain areas is combined sewer. So that means all stormwater is going into with the sanitary sewer, which all ends up at the sewage treatment plant. And in heavy rain events, that becomes overwhelmed and it just overflows straight into the ocean. So what they're trying to do is separate the stormwater out of the sanitary sewer to take that load off of it and not have to treat all of that rainwater that really doesn't require treatment in the first place. Rainwater off the roof of a house is often a higher quality than a lot of groundwater. Couple of Abbotsford, these are more commercial projects. So about 2 years after Abbotsford Centre was built, the city decided to do some water saving measures in city facilities. So we built this system here. And that was kind of a very unique project. We did it kind of as a promotion. So ourselves, the plumber, the electrician actually donated. We donated the product, they donated their time and materials in exchange for season's tickets and promotion advertising in the facility. So we put that system together within about a month period. And so we're collecting off of one downspout out of 10 off that roof. And that's a 4,000 gallon system, 12,000 liter. It's collecting water to feed the Zambonis to maintain the ice surface. So the water comes in, you can see the black box on top, that's the pre-filter. Water goes in, it gets pumped from the tanks into the hot water heaters for the Zamboni. Plus it goes through I think a 50 micron bag filter before that, so the water going into the water heaters is very clean. And then it's filled the Zambonis, they fill up 200 gallons at a time, they go treat the ice. And so it has the potential, this system alone has the potential to collect up to 1.5 million liters a year. So you can imagine that times 10. If they would have collected rainwater off that whole facility, I really tried hard to get that system in when they were building, but they were over budget, they didn't put it in. They could have done all of their own irrigation and toilet flushing, plus probably provided water to UFE or somebody else in the area as well, if they would have done that.
They still could. There's a parking lot there.
Yeah, it costs so much to retrofit though. You know, that's the problem. When you're building, it's easy.
Yeah.
It's half the cost or less. Just another interesting fact, a couple of them actually. This system will collect 1,200 liters of dew every morning in the summertime. It's a membraned roof, it gets dew on it at night, and it starts to run down, and so it'll collect 1,200 liters of dew every morning. The other bonus they got out of this that they had no concept of when we planned and designed it was the increase in temperature of the water. So if it rains overnight, the tanks fill up. The plant operator, this is in the boiler room too, so in behind there you can see the two big boiler exhaust vents going out. So it's 90 degrees Fahrenheit in that room. So when the water comes in, it's fairly cool. It heated up an average of 20 degrees Celsius over the course of 8 hours. So that dramatically reduced their heating cost for heating the water to go into the Zambonis. So the energy savings on heat were actually double what the savings are on water in value. This is a system at Tradex. This system is 32,000 liters, collecting off of 4,400 square meters of roof, which is a quarter of the building. They can collect up to 6.4 million liters per year with this system. And during a 25 millimeter rainfall event, that tank would fill 3 times off that roof area. So they could potentially add 2 more tanks and really maximize their volume. They talked about adding another one. They had space right beside it there to put 1 more tank, but they still haven't done it. But this is one of the most highly utilized and efficient systems that exists in the Lower Mainland. They will use a tank full of water during a trade show, and they have it connected to all the plumbing fixtures in the bathroom. So all toilets and urinals are flushed with rainwater in this system. And the only reason they did it is they got a federal government grant for municipalities to do, efficiency upgrades, energy efficiency and whatnot. So they got about $1.5 million grant. So they spent it wisely. They upgraded all the fixtures to low flow fixtures. They added insulation to the building. They changed to LED lighting, and they put this rain harvesting system in. And here's another project these projects were all done roughly around the same time for that same program. They had that year a certain amount of money to put into them. So these are both at Abbotsford Works Yard on King Road. So one system is being used for the car wash. So that's where they wash in that tent. They wash all the municipal vehicles, police vehicles, etc. So they're collecting off of that one building, which is about 7,000 square feet, collecting up to 950,000 liters per year. The other system is on the other side of the yard. It's off a 5,000 square foot building, and that's used for their heavy equipment wash station. So all the dump trucks and big trucks that come in full of mud, they can wash them off there and utilize rainwater. Plus they fill mobile equipment like watering tanks for watering the plants, the hanging baskets in the summer, tree watering, and also filling street sweepers and any other kind of mobile equipment, asphalt rollers. They all have water tanks on them, so you can use non-potable water for that instead of drinking water. So now we'll touch on Greywater recycling. We're the Western Canada distributor for Hydroloop. Hydroloop is really coming on big time across the world right now. It's been in development for over 15 years, but it's really gone to market in the last 5. And it's out of Holland, and it is a very advanced greywater recycling system. So why would we want to consider greywater recycling? It's the most efficient and affordable way to use less potable water on site. And what is greywater? There's basically 3 types of water in the home. There's potable water, black water, which is your toilets, sewage, and greywater, which is water from your showers and bathtubs. So what we're using is the water from the showers and bathtubs, and we're putting it through the Hydroloop system, which treats it, stores it, and pumps it back to your toilets and or laundry and irrigation. Can also be used for swimming pool makeup. They offer a few different sizes of systems for different applications, and we can achieve a minimum potable water saving of 25%, but up to 45%. So 25% is flushing toilets, 45% is laundry. So toilet flushing and laundry are the 2 biggest users of water in your home. And we can meet the demand for that. And having said that, for laundry, they don't use the water for every cycle. They only use it for the wash cycle. They use potable water for the rinse cycle. And strangely enough, I'm not even sure exactly how it does it, but Hydroloop can differentiate between the cycles. It's got a very powerful brain inside. So you can imagine, and I'm trying to get somebody from a municipality. I think I've got some interest out of the University of Calgary. They may do a study. We went and did a presentation for them, and they actually bought a unit. And they may do a study on what the value would be to a municipality if they implemented these systems in all new construction. What would be the savings on water? What would be the savings on sewer discharge? And what would the benefit be in dollars to a municipality? And then they can make a decision whether they would want to subsidize or give incentives to developers to put these in. Because developers aren't going to do it on their own. They're just not going to get caught. Anything that costs more money, they won't do without some kind of incentive. Or unless they're forced to, they have to be legislated to. But they're a pretty powerful lobby, so incentives or reduced DCCs, if they could say, oh wow, this is going to save us this much water and this much sewer of this particular project, we can reduce the DCCs by an appropriate amount to make it more attractive to the developer to put it in, and then they get brownie points for building a green development, which some developers are doing that. We have a project on the Sunshine Coast I've been working on it for over 2 years now, and that's what actually got me into Hydroloop, was this guy wants to put it in every one of his units in an 88-unit townhouse development. Plus he wants to do rainwater harvesting for irrigation and the stormwater management. He's required to do the stormwater management, The other two he doesn't have to do, but he wants to do it. And Seashell has no water. They've almost run out 2 years in a row now. They've actually cut off businesses. They cut their, like microbreweries and other businesses that use water, they cut them off of their water. They said, you can't use water, you can't make any beer. So, I mean, because of no water, but I guess I should have went to them and said, you better collect rainwater and treat it and use it for your beer. Because that's been done in multiple places around the world. So, quick overview, water comes into the system through the top. It fills up. Any sediments go down to the bottom cone there and they sit, and they're automatically flushed once every cycle. Any floatables float to the top, skim off the surface and go down the drain. And then the water is aerated. So tiny air bubbles, micro bubbles float up and they collect all small floating particles in the water and they float it up to the surface and skim it over. And then in those other chambers there, those are the treatment chambers, they have a filter media in there, which is the MBBR. So it's a filter media which creates large surface area for bacteria to grow, which consumes waste out of the water. So this treats the system in 4-hour cycles. So every 4 hours, it'll run a treatment cycle, and then the treated water gets stored in the bottom tanks. And this system can do about 180 liters per day. So that's the water savings per day you can get with this system. And very unique. It's actually quite simple. We had the trainer came to our office a little while ago. We had several plumbing contractors came in and took the training course, and we were actually able to completely disassemble the unit in about 40 minutes and put it back together in about 1 hour and 20 minutes. So that's the maximum you would ever run into on service and maintenance on the system for time, but in reality, you're only going to change one little component that may have an issue. It's fully connected. They actually monitor from head office every system installed in the world, and they get alerts if there's anything going wrong with the system. They got a genius that did the programming for the system. He apparently, the founder of Hydroloop had a friend whose son has Asperger's, and he's a highly skilled computer programmer. That was his thing. He started working for the company part-time when he was in high school, and when he graduated, he went to work for the company full-time, and that's all he does is operate the program. He actually can make changes to any system from his laptop. Anywhere in the world, he can actually change the system, update the programming. It's pretty amazing.
I'm curious how energy intensive it is to do like this whole system.
It's actually very energy efficient. All the devices in there are very small and energy efficient. I know they have data on power usage, and you have to keep in mind that everything that's manufactured in Europe has power conservation in mind. Everything is very, like systems like this, even the on-site sewage treatment systems, the sewage treatment systems, they don't run all the time, and this doesn't run all the time. It only runs in 4-hour cycles, so it has quite a few rest periods. So it's not running all day, whereas most sewage treatment systems on the market, they run 24/7. They got a blower running 24/7, so they use a fair bit of power, whereas the graph treatment systems in comparison, they use the equivalent energy of a 100-watt light bulb. So that's how much power they use in a day is with a 100-watt light bulb burning all day long. So right now for residential applications, they have 2 different models. They have the H300 for single-family homes, 4 to 5 people, and then the H600 for larger homes of up to 10 people. And it's basically just a double system in one package for the bigger unit. And this, in first quarter 2025, they're releasing Hydroloop Concealed. So that's going to be for small households, 1 to 3 people, suitable for apartments, tiny houses, laneway homes, and retrofitting. So it's basically you can see the different kind of installation configurations. It can be either installed kind of into the wall or basically in an area that's just built out. And it's only going to be probably about 12 inches deep or so. So very compact and space efficient. So they can be built into apartments. So now all of a sudden you can build an apartment building and use 25% less water right off the hop by putting these in each apartment. So it'll collect the water from the shower, goes into the hydro loop, gets treated, gets used for toilet flushing. So very basic system, and also quite a bit less expensive. They're going to go to market probably for around $3,000 a piece. I mean, some toilets are more expensive than that. The H300 for the single family home, roughly $10,000 installed. And then the H600 is going to be in the range of probably $18,000 installed. So not double, but double the capacity. And that's it in a nutshell.